actively participated in 45 workshops, seminars, FDPs, and refresher courses. She is a life member in Indian Society for Probability and Statistics, Society for Development of Statistics, and more on. So I welcome Dr. Rajini ma'am to continue with this FTP,
Yeah,
and I hope it
well,
will be very fruitful for each one of us. Okay.
thank you, ma'am. Thank you so much. And I'm really thankful to you all for giving this opportunity to share my knowledge with you all. So, what I planned is in the coming 3 days, that is today and another 2 days. So, first, I'll be explaining in today what is the statistics, what is the basic knowledge of the statistics, why it is before going for any analysis. You should know what statistical technique can be applied because to solve one problem, we'll be having so many techniques, but you should know for which technique is suitable for which data. So for that one, we'll be learning what is the basic statistics. And after that, in the another 2 days, in the second day, I'll be giving you some questions. Based on that questions, you'll be understanding what analysis can be done, how it can be done using MS Excel. And in the other 2 days, in the third day, I'll be explaining through the case study. I'll be taking one real life data set and then how to do the analysis I'll explain. And if time permits, I'll go for the another case study also and I'll explain the same concepts through the another data set also. So I hope it will be more helpful for your research work and anywhere. Okay. Yeah. Due to network, I'm just switching off my video. Okay. Thank you. Am I audible to you? Is it clear?
Yes, ma'am.
Yes, ma'am. Yeah. Thank you so much. So I'm sharing the screen. Yeah. Can you see the screen, ma'am? Can you
Yes,
all see
ma'am.
the screen?
Yes,
Yeah.
ma'am.
Okay. Now, see, in the actually agenda for these 3 days is for this program to understand the basic statistics for analysis and problem solving using Excel. That is for through the case study and the general problems also. Okay. And first, before going for statistics, first we need to know what is the definition of the statistics, right? So, how can you say what is the statistics? What is the meaning of it? Generally, everybody says that it is it is nothing but the calculation of the average, only collection of the data. And after collecting the data, we do the calculation, we find the average, and that is the statistics. No, not only the average. In statistics, we are having so many steps. Okay, so what are those steps we need to check it? So statistics mainly consists of 5 steps. In any research, these 5 steps only we follow. So knowingly or unknowingly, we do all these steps, but we don't know that this is called as statistics, right? So first one, what is the first step? It is the collection of data. And second one is the organization of the data. And third one is the presentation of the data. Fourth one is the analysis of the data. And fifth one is the interpretation of the numerical data. So what is the meaning of each step? You should know that. So first one, it is the collection of data. So collection of data is nothing but, see, before going for any analysis or any survey, we require some data. Without data, we cannot do prove anything, right? So how we get the data, that is more important. So the data, you may get it through the primary source or the secondary source. So what is the meaning of the primary source? That means what you want to prove or whatever you want to find. For that one, the data is not available. Now you are collecting the data primarily. That means till now the data is not available. You are collecting the fresh data for your research work. So that is called the primary data. And what is the secondary data? It is already somebody have used for their purpose. Okay, they collected and they used and it is done for them. Now we are using the same data for our purpose. So this is called the secondary data. So we are using second time. The same data we are using second time. So that's what we are calling it as a secondary data. Now, once the data is collected, okay, the data is ready with us, then we need to go for the analysis. Okay, by collecting the data, we cannot get any information, right? You need to study what is the data exactly. So for that one, first you need to check what data you have. So you need to arrange the data in a proper format. Okay, so once after collecting the data, any researcher has to do first what data you have. And for example, you are having 10 days of time for your project work. Okay, you have a data. The data is assigned by your HOD to you, and she or he asks you, just give the interpretation of this data in 10 days. So what do you need to do? First, directly you cannot go for the analysis. You need to understand what data it is. Okay, so among that 10 days, you need to spend major time for understanding the data. Example, 70% of the time. That means among 10 days, 7 days you need to use for understanding the data. Once the data is clear, you understood what columns we have, what variables we have, what kind of a data we have, whether it is a qualitative or a quantitative, that everything you need to check. And do we have any missing values in the data? Or do we have any outliers in the data? Do we have any noise in the data? That all the things you need to check it, right? So if we have any relevant data, that all the things we need to check. That is called the organization of the data. That means you will be cleaning the data. You are putting in a proper format. Okay. You are arranging the data in a proper way. Which columns are useful for you? And if there are any missing observations, if it is a very less data, then you need to replace it. If it is a quantitative data, we replace it by mean. If it is a categorical data, we replace it by mode or median. Like that, we need to check. Okay, once it is done, and if you have outliers, you need to check based on your objective that outliers can be included or should be omitted. That is based on your objective will be decided. Okay, once the organization of the data is done, that means cleaning the data is over. Then what we do that we present the data. So what is the meaning of the presentation of the data? That means we understand what are the basic characteristics of the data. Okay, basic characteristics of the data, that is called the exploratory data analysis. Okay, so any layman, if a person is seeing the data, should understand what data we have. Then how will understand? But if you are showing any Excel file, will they understand? No. If you are representing that Excel file in a beautiful diagrams and the graphs, then any layman also will understand what data you are having, what is the work you have done for it. You will be understand. That means anybody can be understanding. Clear. So that is presentation of the data is also plays a very pivotal role in the data analysis. Okay. And next one, once the presentation is done, that means through the presentation, we'll be understanding what are the characteristics of the data. Once if it is done, that means 70% of the time we used for organization of the data and presentation of the data. Then remain among 30% of time, 20% of the time you need to use for analysis of the data. To analyze the data, what statistical technique we have to apply, that you can understand based on your understanding of the variables. Okay, so analysis of the data also plays a very important role in the statistics. Okay, and remember in machine learning, one saying it is there: garbage in, garbage out. That means once the data is not cleaned properly, then whatever the analysis you are applying, the best method you are applying, even though the result will be worst. Okay, so that's what you need to be very careful about, understanding the data and cleaning the data. Then after that, we go for the analyzing the data. Okay, in analysis, we apply so and so particular statistical techniques, and then we get a result. Once the result is done, then in the result you'll be getting so many values. Okay, so many values. Among all the values, okay, once you have applied your data to the one Python programming or in Excel or in a R programming, okay, then after applying the statistical technique, so many values will be displayed on the screen. then you could able to understand which values are useful for giving the conclusion. That is called the interpretation of the numerical data. Anybody can do the analysis, but interpretation can be given only by the person who understand the data very well. Okay, so this is the main definition of the statistics. Okay, so what is that? Statistics consists of collection of the data, organization of the data, presentation of the data, analysis of the data, and interpretation of the data. All five steps together will call it as a statistics. So in any research, if you are following these steps, then the result will be perfect. Okay, so do you have any doubts in it? Is it clear, everyone? The definition is clear?
Yes.
Yes, ma'am.
Yeah, thank you. And next, go for the measures of central tendency. I told that once the data is clear, then we need to apply the statistical techniques. So, in the statistical techniques, before going for the analysis of the data, you need to check what is the descriptive statistics of the data. So descriptive statistics is nothing but, see, through the diagrams, we understand what are the few characteristics of the data. And the characteristics you want to show in a numerical values. So through the diagrams, it is not possible. So in that case, we are going for some basic statistics. So in that one, the first main step is measures of central tendency. So measures of central tendency is nothing but concentration of all values around a center value. Okay, concentration of all values around a center value is called a central tendency. So what is the meaning of the central tendency? That will check it. Yeah, see, let me tell you what is the meaning of central tendency. For example, I'm running a one business, right? I'm running a one business from past 5 years. So, in what is that? In 2020, 2021, 22, 23, 24. And I've said, taken what are the sales? Okay, let me go for the what are the profits? Okay, what are the profits of this? Okay. What are the profits of that particular product? What I'm having a business. In that one, in the 2020, it is a beginning year, I got a profit of 10 lakhs. In the next year, I got a profit of 9 lakhs. In the next year, it is a 12 lakhs. And next year, it is a 19 lakhs. And in the next year, it is a 18 lakhs. So this is the data I have. Now, for example, if somebody asks me, okay, example, my brother only asked me. So on an average, in these 5 years, what is the profit you got it? Okay, among that means among all these 5 years, what is the profit you got it? That you need to check. Okay, that he asked me. Then I told that I got it, and on an average, it is a 14 lakhs of that particular item. Then how did I get this 14 lakhs? Okay, I did not say that in the first year 10 lakhs, in the second year 9 lakhs, in the third year 12 lakhs, in the fourth year 19 lakhs, in the fifth year 18 lakhs. Like that, I did not say. I told that 14 lakhs I got it. On an average, in all these 4 years, I got 14 lakhs of profit. Right? Then how did I get this 14 lakhs? This is called the central tendency. So central value. So it is giving that all these values are concentrating around this center value. Then this is called the central tendency. Clear? And to measure this central tendency, what method we are using? That is called the measure of central tendency. Clear? So central tendency is nothing but what? How all the values are concentrating on a center value. To measure that center value, we are using some methods that all are called as a measures of central tendency. Is it clear? Central tendency,
Yes,
everyone?
ma'am.
Yeah, thank you. Now, you just see, now, see, to calculate this 14, which method I adopted that I need to say? right? So to calculate the central tendency, we are not having one method. We are having five methods: arithmetic mean and median, geometric mean, harmonic mean, and mode. These are the five methods which we are having to calculate the center value. So now there is a question. To calculate the center value, one method is enough. Then why do we require all these methods? Right. So before going for this, you need to know what data we have. Okay. So the data, whatever we are having, that is divided into the two ways. Okay. One, it is a quantitative data. Okay. That means which can be measurable, okay, which can be measurable. And next one is qualitative data. Okay, next one is what? Qualitative data, which cannot be measurable. Okay, based on this one only, we apply a statistical techniques. Okay, so now you just check it. If the data is quantitative, what is the meaning of this? That means a method, that means any variable can be measurable. For example, how many kgs of rice, how many kgs of rice you are using per month. Okay, how many kgs of rice you are using per month. Okay, that is nothing but how many kgs that can be measurable. It is 20 kgs, 10 kgs, 7 kgs, 30 kgs, like that we are telling. So which can be measurable, right? So this is called the quantitative data. Okay, and suppose here I'm asking what rice you are using, what rice you are using. For example, you will be having sona masuri, okay, and next one boiled rice. Okay, like that there will be so many different kinds of the rice, right? So in that case, what it is, what quality you are using, that cannot be measurable, that can be understand, that can be observed. So that is called the qualitative data. So remember, a variable which can be measurable is a quantitative data, and if the variable is not measurable, that is called the qualitative data. Okay, so this is what you need to know. So if the data is quantitative, okay, remember, if the data is quantitative, that means which can be measurable. In that case, we can apply arithmetic mean and geometric mean, harmonic mean, and next median also. And next, if the data is qualitative, to find the average or to find the center value, we can use either the median or the mode, right? So these are the methods you need to apply. Now again, there will be a question. If the data is quantitative, one method is enough. Why are we moving to so many methods, right? So we apply arithmetic mean. Once in the data, if you are not having any outliers, okay, in the data, if you are not having any outliers, what is the meaning of outliers? That means outlier means which is not common value, which what all other values we are having. Okay, for example, here I told that I started my business in 2020, 21, 22, 23, 24. In first year I got it, it is a 10 lakhs, and in the second year it is 3 lakhs, and in the third year 15 and 18, 19. Just see, all the values are nearby only, but this 3 is completely odd man out. Okay, so the value which is not related to all the values, then this is called the outlier. Okay, easily you can understand by seeing the values itself whether the particular value is related to all the values, that means nearer to all the values, or extreme values if we are having. So that extreme values are called the outliers. Okay, so if the data consists outliers, we cannot go for the arithmetic mean. Now, just go for the median. If the data consists outliers, then we go for median. Remember that. And next one, when we go for the harmonic mean and the geometric mean. So remember, harmonic and geometric mean, we apply for rates or ratios of the data. If you want to find rates or ratios of the data, we go for harmonic mean and geometric mean. So in the harmonic mean, when we apply, if we are talking about the time and distance, okay, if you are talking about the time and distance, which is a quantified, then we go for this qualitative data and quantitative data. And next, geometric mean, when we apply, if we are having time and what is that, financial context. Okay, if we are having time and financial context, we apply the geometric mean. Remember that. That means if there is a multiplicative change, okay, if there is a multiplicative change in the values, we apply this geometric mean. Clear? So remember, if the data is related to time, then we can apply either the geometric mean, harmonic mean, which gives a perfect answer than arithmetic mean and the median. Okay, so I hope it is clear. Any doubt in the quantitative data measures? Is it
No,
clear?
ma'am. Yes, ma'am.
Yeah, thank you. And now just go for the median. An example I'll tell you. Example of each method also I'll tell you. Then later it will be easy for you. For example, I'm just wanted to know what are the marks of the students. Okay, what are the marks of the students? So here the students, first student got a 20 marks, next student got 25 out of 30, next student got 28, 18, 15, 12, 10, like that he got it. Okay, these are the marks of the students. Now in this case, we are not having any outliers, so we can apply arithmetic mean. Okay, and next one, here when we are applying the median, I told that if the data consists outliers. Okay, for example, if you are going to take admission for your daughter in any one college, okay, for engineering, then what do you check it first? How the placements are there in a particular college, right? So in that case, what is the management will tell you? They say that median package in our campus is, it is 8 lakhs per annum. So why they did not give a average value, arithmetic mean value? Because it is not necessary that everybody will get the same person, same package, right? So example, in a college, example I'm telling you, in a college there are 10 students. So one student got 3 lakhs and one student got, another student got 3 lakhs and next student got 7 lakhs, next student got 8 lakhs and next student got 10 lakhs and next student got 15 lakhs and 20 lakhs, like that it is there. Okay, so now here what is that, here the different packages are there, right? Suppose if I'm giving the average value, it will be different. Okay, which may not give the proper result. Here why it is not giving? Extreme values we are having, right? Extreme values we are having. Okay, then in that case we go for the median. So we say that the average package in the campus for the students is 8 lakhs per annum, right? And next one, when we are applying the harmonic mean, just see, suppose if I'm having the different weightage, see, I'm traveling from one place to another place. Okay, so it is total, what is that? It is for the first half an hour, I traveled for 60 kilometer per hour. And next half an hour, I traveled for 40 kilometers per hour. Right? So what is that? Journey is same, but I'm using different time periods. Okay, sorry, in the same time, we are using the different values. Okay, so what is that? When I'm traveling a fixed distance at a different speed, okay, fixed distance at a different speed, okay, then in that case we go for the harmonic mean. Okay, so first 60 kilometers I traveled for kilometer per hour, next 60 meters I traveled for 40 kilometers per hour, right? So 60 distance is same only, but the speed is changing, then in that case, we apply harmonic mean. So remember that the distance is same, right? The distance is same, but we are using the different speed. So in that case, we go for harmonic mean, right? And next one, when we are applying the geometric mean, for example, I just invested my amount in particular some mutual fund. Okay, in one mutual fund, I invested my amount. So in the first year, I got 10% of growth in the particular item of that particular fund, and in the next one I got minus 5% decrease in the fund, and next I got it 18% increase in the fund. So what it is, in the 3 years, in the last 3 years, what is the growth of a particular item? I checked it. So what it is, here I'm talking about the percentage of change. You're talking about the growth rate. Okay. If you're concentrating on the growth rate, we apply the geometric mean. Clear? So in the first year, I got a 10% of growth, and in the second year, minus 5% of a growth, and third year, 18% of a growth. So if you are talking about this growth rate, okay, if you want to know what is the change in the percentage change in the data, if you're talking about a rate, then we go for geometric mean, right? And then we are going for the qualitative data. So what is the meaning of the qualitative data? That means which cannot be measurable. Okay, for example, here I'm telling that what it is. Here I'm telling, uh, I just asked you one question. Just rate me in a chat box how I am teaching. Okay, I asked you to rate in between 1 to 5. 5 is the maximum value. That means it is a satisfied, and that means very satisfied. 1 means dissatisfied. So I'm telling that 5 means very satisfied, and 4 means satisfied, and 3 means neutral, and 2 means it is dissatisfied, and 1 means it is a very dissatisfied. Okay, now this is a question I have given to you. Then you answered to my question. So what it is, there are 7 people are there in my class. So they told that few of the people, what it is, one person told 5, another person told 3, another person told 1, next person told 5, and next 4, and next 3, next 1. So what is that? Here it is, all the values are arranged in a one order. Okay, that is called the ordinal data. The values can be arranged in a proper order. So what I can say, 1 to 5 values can be arranged or not. 1 means very dissatisfied, 5 means very satisfied. That means there is a particular order between minimum value to the maximum value. Then in that case, to calculate the center value, we apply median. So in this one, what is the median value? 1, 1, 3, 3, 4, 5, 5. So what is the meaning of this? We need to go for the central value in the median. First, you need to arrange the data in ascending order and check it which is the middle term. Here 3 is the middle term. So in my class, average of the, that means average of my class teaching is what? It is neutral. The students are not dissatisfied and not satisfied. They are okay with me, right? So this is the way to find the median value. Clear? And next one, go for the mode. When we apply the mode, so if the data is not ordinal, so what is the meaning of that? If the data is not ordinal, that means which cannot be arranged in a proper order, then in that case, we go for this mode calculation. Okay. For example, here see, what is that? In what phase I have to teach a class in this session? I have to decide. Then I asked Jyoti ma'am, are these people, are these attendees are faculty or students? Okay. If it is a faculty, are these our background of mathematics or not? So ma'am told that mathematics background are 3 people, and arts people are, it is a 7 members, and next commerce people are, it is a 15 members. Okay, then Among all this, what I decide, okay, there are total 25 participants are there, right? Then what I decide, more are commerce people, right? So I should give examples related to the commerce because all the people may understand very easily. Clear? So based on the maximum frequency, I'm deciding what can I teach in the class, right? So this is called the mode. Can I arrange these values in according to the importance? See, in a what is that? In a graduation, all streams are equally important. Mathematics, arts, commerce, all are equally important. I cannot say that commerce is best than mathematics. Mathematics is best than commerce and arts. Like that, I cannot say. All are equally important. So in that case, to find the central value, we apply the mode calculation. Clear? So this is called the measures of central tendency. Is it clear, everyone? Did you understand when to apply which method?
Yes, ma'am. Yes, ma'am.
Okay, thank you so much. Yeah, suppose if I'm going little fast, please let me know. I'll slow down. Actually, my face of teaching is little fast. Suppose if you're not understanding anywhere, you please let me know. I'll slow down. Okay, yeah. And next one. So this is done. Measures of central tendency is done. Then go for the next one, measures of dispersion. What is the meaning of measures of dispersion? Just see, I told that what it is, what are the average sales of my company? It is 14 lakhs, I told. Is it same in all 5 years from day one to till date? No, it is varying. In the first year, it is 10 lakhs. In the next year, it is 4 lakhs. In the next year, it is 15 lakhs. In next year, it is 18 lakhs. Like that, it is there. That means from actual value to center value or actual value to estimated value. What is the difference we are having? To calculate the difference, we go for measures of dispersion. Clear? So measures of dispersion means what? It is nothing but calculation of the error. What is the meaning of error? The difference between the actual value and the estimated value. Is it right? For example, I asked one student how many marks you will be scoring in the final exam. So he told me its final exams are done. So he told me, ma'am, I may get it around 70 marks out of 100. Okay. Then after getting a result, I saw that the marks are 60 only. Then what it is? Actually, he told it is a 70. So that 70, what he told, it is estimated value. Okay, it is estimated value. It was, that means estimated means it is a guess. And what is the actual value? 60, he got it. So the difference between 60 and 70, how much it is, that is called the dispersion. So dispersion is nothing but the deviation from center value to all the observations is called the dispersion. So to calculate this dispersion, we are having two different types of the methods. Okay. Yeah. So to calculate this difference, we are having two different types of the methods. So what are those? First one, dispersion. Yeah. In this one, two methods. What is that? First one, absolute dispersion. Okay. And next one, relative dispersions. So what is the difference between absolute and relative? That is, if you want to, if you just you have a data and you will calculate how much variation is there in the data, then you go for an absolute variation. Just you will say that how much variation in the data, that's it. You're not going for any comparison. Then we go for absolute dispersions, right? And next one, what is the meaning of a relative dispersion? So relative dispersion is nothing but if you wanted to compare between any two or more than two, then we go for relative dispersion. So example, here I'm telling that I have a two sections of classes. Okay, two sections of statistics class. Okay, statistics, for statistics there are two sections, section A, section B. Now I wanted to see which section is best than other. Now here what I'm doing, I'm comparing here. So for that comparison, so which method we apply? It is a relative measures. Suppose if I'm asking, what is the deviation of the A student's marks? What is the deviation in the B student's marks? Separately you are calculating, then it is an absolute dispersion. Suppose if you are going for the comparison, then we go for the relative dispersions. Right? Is it clear, everyone? What is the absolute and relative? Can I get a reply?
Ma'am, what is
Yes, ma'am.
absolute relative I understood that there is a comparison, but absolute or relative.
Okay, 1 minute. Let me tell you. See, example, I have taken marks of A section and marks of students in B section. Okay, see, marks of A students marks is, it is 30 out of 50. Marks of B section student is 40 out of 50. Then average, these are the average marks of the students. So what do you feel that? You say that this 40 is high. Then what is the conclusion you say? Marks B, that means section B is very good students than section A. Right? So it is wrong. If you are giving the conclusion based on the average, it is wrong. Clear? So you need to calculate what is the dispersion. Okay, what is the dispersion? That means actual value to the center value. How much it is there in the section A? It is only 10 marks difference. And in section B, it is a 20 marks difference. Then what do you say that? Yes, section A students are scoring less marks. Even the students' deviation is very less if you are comparing with the student deviation in B section. So I say that section A students are consistent. So what is the meaning of consistent? That means in section A, all the students are studying in a same way. There is no much deviation. But in section B, what? There are, it is a deviation is 20. That means few students are getting good marks and few students are getting less marks. That means in section B, it is not consistent. That means only few students are performing well comparing with all other. Okay, so if you are calculating the dispersion of section A, it is absolute dispersion. Calculating the dispersion of section B, it is absolute dispersion. But if you are going for the comparison, okay, if you want to go for the comparison, we go for the relative measures. Okay, we go for the relative measures. Clear? So relative measures are nothing but only based on the absolute dispersion we cannot say. You need to say what is the percentage of the variation. Okay, you have to say what is the percentage of the variation in section A and section B. Then we go for relative measures. If you wanted to find only the deviation, absolute dispersion. If you are going for the comparison, that means you will be calculating the percentage of deviation in the data. Then we go for relative measures. Yeah. Is it clear, ma?
Yes, ma'am.
Okay, thank you. So this is we did it. Okay, among all the dispersion, remember, if the data is qualitative, then go for the quartile deviation in absolute, and in a relative, you need to go for the coefficient of quartile deviation. Clear? And next, if the data is quantitative, apply the standard deviation to calculate the absolute value and coefficient of variation for the comparison. That means these two comes under the absolute measures and these two comes under the relative measures. So you need to know for which data, which method should be applied. Clear? So with this, I'm just ending the measures of dispersion. Is it clear? Measures of dispersion is it clear, ma'am?
Yes,
Yes?
ma'am.
Yes, ma'am.
Yeah, thank you. Now, go for the, yeah, yeah. Now go for the next topic, correlation. So next topic is correlation. So correlation is nothing but what? Suppose I mean, see, is it necessary that when you are going for any research work, will you be having only the one variable in the data? No, you'll be having n number of variables, right? And you wanted to know how that means how the variables are related. Okay, you wanted to know how the variables are related, which variables are having a relation. So for that case, we go for the correlation analysis. Clear? So in the correlation, again we are having three types of the correlations, right? So first one is what? First one, it is a positive correlation, negative correlation, and zero correlation. And second one is what? It is a simple correlation, partial correlation, and multiple correlation. Okay. Third one is what? Linear correlation and non-linear correlation. So these are the three different types of correlations we are having. So what is the meaning of the first type? So first type is what? Positive, negative, and zero. So what is the meaning of all these correlations? So positive correlation means the variables whatever you have, okay, that variables moves in the same direction. Okay, the variables moves in the same direction. Then we say that the variables are having a positive correlation. That means if x increases, y also increases. If x decreases, y also decreases. That means, example, x is taking the values 2, 3, 4, 5, and y is taking the values 20, 30, 40, 50. Right? That means x is increasing, y is also increasing. That means both the variables are moving in the same direction. Then we say that x and y are having positive correlation. Got it. And now move to the negative correlation. So what is the meaning of the negative correlation? If x and y are having negative relation, that means both the variables are that means moving in a opposite direction. So both the variables are moving in a opposite direction. Okay. So what it is here? If x increases, then y decreases. If x decreases, y increases. So you just check it what it is. That means there is a negative correlation. That means if x is taking the values 1, 2, 3, 4, 5, and y is taking the values 50, 40, 30, 20, 10. That means what? X is decreasing, x is increasing, y is decreasing. Then we say that x and y are having negative correlation. Is it clear? So here what it is, if x increases, y may decrease. If x decreases, y may increase. So here we say that both the variables are having negative correlation. Now just move to the next one, zero correlation. So zero correlation means you're not understanding what relation exists between the data. It is zero. That means both the variables are uncorrelated. Okay, both the variables are not at all having any relation between the variables. So that is called the zero correlation. So zero correlation means what? Both the variables are not having any relation. So in a diagrammatic presentation, how can we say that? If whenever you are plotting the values on the graph, if all the points are like this in increasing trend, then we say that it is a positive correlation. And if plotted points are in like this in a decreasing trend, that means here we understand that there is a negative correlation. And when you plot all the values, you are getting like this circle type. Okay, that means there is a zero correlation. Clear? So this is the first type. Is it clear? The type 1 is clear, everyone?
Yes, ma'am.
Yeah, thank you, ma'am. So now just move to the second type. So what is the second type? It is a simple, partial, multiple correlations. Okay, simple correlation means what? You'll be having only the two variables and you will be finding the relation between that two variables only. Then we say that there is a simple correlation. Okay, and next one, we go for the simple correlation means what? If there are only the two variables, you are focusing on only two variables. You are not having any consideration of the other variables. Clear? So that is called the simple correlation. And go for the partial correlation. Suppose if you are having more than two variables in the data and I want to find the relation between only two variables by eliminating the effect of the other variable. Okay, for example, here I'm taking I want to buy one car. Okay, I wanted to buy one car. So what did I tell you? Sorry, what I checked is it is what is the mileage of the car and what is the type of the car. Okay, what is the type of the car? Here, these two only I'm checking. Then in that case, we apply simple correlation. But along with this, I'm taking what is the road condition. So I'm taking what is the road condition. So based on the road condition also the mileage will be changing. Is it right or not? See, whenever you are driving on a highway road, it gives a more mileage when you are comparing with when you are driving in a city roads. Right? That means what it is, road condition also plays a very important role. Right? So now what I wanted to find what it is relation between the mileage and type of a car. By keeping the third variable as a constant, you are not finding any effect on these two variables. Keeping the effect of a third variable as a constant, then we go for this partial correlation. Clear? So partial correlation means what? We will have more than two variables but you wanted to find the relation between only the two variables by keeping all other remaining variables as constant. Clear? And next one, sorry, and next one, multiple correlation. So what is the meaning of the multiple correlation? I wanted to find the relation among all the variables. How the mileage is depending based on the type of a car and based on the road condition of a in a particular area where I travel. So here if I'm finding the relation among all the variables, then we go for this multiple correlation. Okay, so now is it clear? Everyone's second type is clear?
Yes.
Yes.
Yeah, thank you. And next one, linear and non-linear correlation. So linear and non-linear correlation. So what is the meaning of this? If there is a linear relation between the variables, that is here when I have plotted the values on the graph, you are getting the data like this. Okay, when you plotted the values on the graph, you got a data like this, either increasing or decreasing. Okay, then in that case, to find the correlation, we go for this one, what it is, linear correlation. And next, suppose when you plotted the values on the graph and the graph is showing like this. Okay, the graph is showing like this, then in that case it is what? It is not an increasing or in decreasing. You are having the data like curve shape. Then in that case, we go for non-linear correlation. Okay, this is a one way to find. And next one, another way is, for example, I have a data like this, y is equal to 2x. Okay, so x is taking the values 1, 2, 3. Then y will be what? That is, if x is 1, y is equal to 2. If x is 2, y is equal to 4. If x is 3, y is equal to 6. Right? Now here, just see what is the relation between these two values. It is 2. Difference between 4 and minus 2 is 2. And difference between 6 and 4 is also 2. Right? So the difference is same. Then in that case, we go for linear correlation. Okay, next one, if I'm telling that y is equal to 2x square, x is what? It's taking 1, 2, 3. Y is what? Then if x is 1, it is a 2. If x is 2, 8. If x is 3, 9 twos are 18. Check the difference. What do you have? Here it is a 6 and here it is a 10. Right. So in this case, we have to go for non-linear correlation to find the relation between the variables. Is it clear, everyone? Type of correlations. Can I
Yes,
get a
ma'am.
reply?
Yes,
Oh,
ma'am.
thank you so much, ma'am. Yeah, so with this we finished. So all this measures of central tendency, measures of dispersion, and this one, what it is correlation. This everything comes under the descriptive statistics. Okay, now we are moving to the next one. Yeah, next one is what? Yeah, next one is regression. So when we are applying the regression, so through the regression analysis, we can find what is the correlation, and not only that, you can predict the future value. So if you want to predict the future value, we go for regression analysis. Okay, and remember in the regression also we are having two kinds: linear regression, non-linear regression. So just by applying the data on a graphical presentation, you will understand easily. Okay, so what it is, regression analysis we apply to find the relation between the variables and also to find what is the predicted value for the data. Okay, so now you just check it here. Yeah, so here what is the correlation, sorry, what is the regression, we'll check it. See, suppose example, I have x and y. X value is 1 2 3 4 and y value is 10 3 15 and question mark. Here this is what I wanted to find. Okay, if x is equal to 4, then y is equal to what you need to find. In that case, we go for regression analysis. Clear, everyone? So to apply regression analysis, you need to know what is a dependent variable and what is a independent variable. Okay, so now tell me what is the dependent variable and independent variable? Independent variable means based on which what you are calculating. Okay, so dependent variable means what? Based on the independent variable, you will be finding something. Okay, so here in this data, x is a independent variable and y is a dependent variable. Why it is a dependent variable? Because they mention x is equal 4. They have given to you. Then you are predicting some value. If x is equal to 4, what is the y value? You are finding. Then this is called the exploratory data analysis. And in the, sorry, this is called the regression analysis. Clear, everyone? So x is a independent, y is a dependent. Now you just tell me, suppose here I'm telling sales. Sales is equal to 10, 12, 13 and profit is equal to, it is 5, 3. Then I wanted to find what is the value. Here in this context, tell me what is the independent variable and what is the dependent variable. Let me know any one of you. If you understand what is the independent and what is the dependent, then only you can apply the
Depend.
regression analysis. Yeah. Depend
Sales, sales is independent.
sales is dependent. I did not get it.
Independent,
Independent.
independent,
Very
independent,
good.
and
Very
profit
good.
is dependent.
Independent.
Okay, fine. Very good. So profit is a dependent
Dependent.
variable. Okay. So based on this, we'll go for the analysis again. Okay. So again here you need to know. Generally in regression, again here we are having two types of the regression analysis. One is what it is normal, generally what is that, general regression and logistic regression. So remember this very clearly when to apply these methods. So general normal regression means what? If the dependent variable, if the dependent variable is quantitative, okay, if the dependent variable is quantitative, then we apply the normal regression analysis. If the dependent variable is qualitative. Then we apply logistic regression. Now you just see in this one, in this example, the variable sales and profits can be measurable or not?
Yes.
Yes or no?
Yes, ma'am.
Yes.
Yes, very good. Sales and profits are measurable. Yes. So you told me that profit is a dependent variable. So which can be measurable. So in that case, I wanted to know if sales is equal to 13, what is the profit? Then in that case, I apply the regression analysis. Why? Because the dependent variable is a quantitative variable. Okay, now suppose if I'm just giving the data, sales, and I'm just giving uh, profit, it is not a profit, what I can say, okay, just take it as a profit only. Here I'm telling that loss or gain. Okay, loss or gain. This is only I'm taking. So what is that? Will you quantify this? Loss or gain? You are observing it. Okay, you are observing which cannot be measurable. This is through the observation you are telling whether it is a loss or whether it is a gain. Right? So in this case, this variable is a qualitative variable. Clear. If the dependent variable is a qualitative, then to find the future value, we apply the logistic regression. So this is what you need to know. Most of the people without knowing will apply the logistic regression. Then in that case, you'll be getting the wrong result. Okay. So here I hope you understood. Any doubt in the regression?
No, ma'am.
No, ma'am.
Is it clear? Yeah. Remember, for example, here I'm telling that gender. Okay, gender based on the hair quantity. Based on the hair quantity, I'm telling that whether the person is a female or a male. Okay, now I wanted to know if hair quantity is some amount, it is 30 units. Okay, then what can be the gender? Okay, what can be the gender? So here is what? Gender is a qualitative variable. Okay, gender is a qualitative variable. Then you need to find the gender. So here in this situation, we apply logistic regression than general regression. Is it clear, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yeah.
Yeah, thank you. So it is very important one and you need to remember this point. Okay, and next, with this, I'm finishing the simple basic techniques in the general statistics. And the next one, we are getting into the inferential statistics. So inferential statistics is nothing but based on the sample, you are giving the conclusion to the population. Okay, based on the sample, you are giving the characteristics to the population. Then that is called the inferential statistics. Okay, for example, in the class, okay, in the class, there are 30 faculty members are there. Now, here, what I'm teaching, whether you are understanding or not, just I'm asking you in between. Only 3 to 4 faculty members are replying yes or no. That means through that four answers, I'm just giving the conclusion that the entire all 30 faculty members are understanding or not. So this is called the inferential statistics. That means through the four members, I'm giving the conclusion to the 30 members, right? So through the sample, I'm giving the conclusion to the population. So this example comes under the inferential statistics. And not only that, in another case, just see, I'm just cooking a bowl of rice. Now I wanted to know whether the rice has cooked or not. How will I check? I check only 3 to 4 grains. Based on the 3 to 4 grains, testing of the 3 to 4 grains, I will decide whether the bowl of rice is cooked or not. Right? That means based on the sample, you are giving the conclusion to the population. So this is called the inferential statistics. Is it clear, ma'am? What is the inferential statistics?
Yes, ma'am.
Yes, ma'am.
Yeah, thank you so much. Now, before going for the inferential statistics, that means through the sample, you wanted to give the conclusion to the population. Then, for that, before going for that, you need to know small, simple definitions, basic definitions. Okay, so first definition, population. So population means what? It is a what it is set of all units. It is called a that means aggregate of units which are possessing the same characteristics is called the population. Clear? For example, here what it is, all 30 members are there. All 30 members are faculty members only. So the characteristic of the population is what? Faculty. Okay. So all the units are possessing the same characteristics. That is called the population. Next, sample. Sample is nothing but it is a part of the population. So what is the use of selection of the sample? That means through the sample, you are investigating the population, right? So to investigate the population, we go for a sample. Okay, next one, just go for the hypothesis. So it is very important. Hypothesis is nothing but any statement or assumption about the parameters involved in the para population. Okay, so what is that? Any statement or assumptions involved or about the parameters involved in the population is called the hypothesis. Clear? And what is the null hypothesis? It is a basic assumption. Okay, in the beginning, to prove or disprove something, first you need to assume something, right? So the basic assumption before going to go for your analysis, that is called the null hypothesis. Clear, everyone? So null hypothesis, for example, I have a one pharmaceutical company. To reduce one particular disease, I'm having two drugs. Okay, two drugs, drug A, drug B. Now, I wanted to check whether both the drugs are, that means just check it. I wanted to say drug B is more efficient than drug A. This is or not, I need to check. So, in the beginning, what I assume before going for any analysis, I assume that drug A and drug B are equally effective. Then that is called the null hypothesis. Clear? And alternative hypothesis means what? I say that drug A is more efficient than drug B. Okay, so the complementary of the null hypothesis is called the alternative hypothesis. Okay, so hypothesis is nothing but nothing. It is only the assumption. So based on your research objective, you need to frame the assumptions of the data hypothesis. Clear? So is it clear, everyone? The basic
Yes, ma'am.
definitions.
Yes, ma'am. Yes.
Thank you so much. And now, so now I framed the hypothesis, right? So
Ma'am,
after
I have doubt in ma'am, Rajini ma'am.
yes, ma'am, tell me.
I have doubt in null hypothesis as well as in alternate hypothesis
Yes,
because
ma'am, tell me.
uh, how to frame that hypothesis and how we'll come to know that whether we have proved it or not.
Ma'am, that is, now if I'm telling you theoretically, you'll not understand. Tomorrow, I'll be going for the some problems, right? And day after tomorrow, I'll be going for the case study. Then practically, I'll show you how to frame the null hypothesis and alternative. It will be easy for you. Okay.
Okay,
So,
one more thing I want to just tell you, ma'am, that
yes,
suppose whenever we are framing null hypothesis, always we have to write negative part in the null hypothesis or positive part in the null
no,
hypothesis.
it is not like that. It is not like that. We assume, for example, if you are going for anything, okay, based on your objective only, you will be deciding, okay, what you wanted to prove. Based on that only, you'll be taking. It is not that always it is a positive side and always it is a negative. It may or may not. See, example. Here I'm taking H naught. If I'm assuming that average marks of the students average marks of the student. If I'm taking 60, exact null hypothesis. If I'm taking mu less than 60, this is also null hypothesis. And H1 in that context is what? Mu greater than 60, right? If it is a equal to, in this one, these two, the first one is a null hypothesis, second one is an alternative hypothesis. What is the meaning of this? I'll let you know while doing a problem. Okay. And if you're taking H naught, mu is equal to 60, H1, it you can take not equal to 60, then in that scenario, it can be greater than 60 or less than 60. Can be anything. I cannot say, right? It is not equal to 60 means it can be greater than or less than. So this is called the two-tailed test. Suppose if I wanted to test less than 60, then it is called the left-tailed test. If I wanted to test mu average marks is greater than 60, then we'll call it as a right-tailed test. So based on the alternative hypothesis, we go for the conclusion. So alternative hypothesis plays a very important role. So how to write this alternative and null hypothesis, that is I'll let you know while doing the problem. Okay, ma'am?
Yes, ma'am. Thank you, ma'am.
Yeah. So you just remind me once again while explaining in the within the case study. So if I'm not explaining this one, whatever the doubt you are having, remind me once, then I'll let you know. Okay. Yeah. So once after the testing, that means now here, what is the question here? This is, see, what is the question here? I wanted to see, I wanted to check in my class, all the students are above average students, or this is what I want to check. In my class, all the students are above average that I wanted to take. Okay, this is what I wanted to test. So in the beginning, what I'm taking, all the students are okay. Scoring is 60. Okay, average students I'm taking. Okay, so here in this case, what now? What is I have to prove? That I have framed the hypothesis H naught and H1. Sorry, this is H naught and H1. I wanted to check average score of the class is 60 or more than 60. This is what I wanted to test. So for this one, what I need to do? First, you need to collect the data. Right. First step, you need to collect the data. After that, you need to frame the hypothesis. And third one, based on the hypothesis, you need to decide which test we need to apply. And based on the test, we write the test statistic. Test statistic is nothing but the formula related to the test. And next, based on the test statistic, we get one value. Through that value, we give the conclusion. So whether to accept H naught or reject H naught. Okay, so these are the 5 steps you need to check in testing of hypothesis. So the flow chart I'll be showing you. This is. So what is that? First, you need to collect the data, state the hypothesis based on your objective, then decide which test you need to apply. So based on the test, you need to write the test statistic. That is a formula. So you'll be getting a value. Through that value, you need to take a decision whether to accept H naught or reject H naught. Clear? So these are the main steps we follow in testing of hypothesis. Yeah. Is it clear, ma'am? What is the testing of hypothesis is clear?
Yes, ma'am.
Yeah, thank you. Yeah. And next, in testing of hypothesis again, you are having so many tests. Okay. In testing of hypothesis, we are having so many tests. Okay. So for example, we are having large sample test and small sample tests. Okay, small sample test. So what is the meaning of large sample and the small sample? If the sample size is very large, generally, in general case, we say that if the sample size is more than 30, we apply the last sample test. If the sample size is less than 30 or equal to 30, we apply the small sample test. Okay. Then when to use last sample, when to use small sample, we understood. Again, there are some conditions. Okay. What are the conditions? if the population variance is unknown, okay, if the population variance is unknown, then we apply small sample test only, irrespective of the sample size. Remember, if the population variance is unknown, irrespective of the sample size, we apply small sample test only. Got it? So this is the one thing you need to remember. So now I'm going to cover small sample tests. Okay, I'm going to cover small sample tests. So small sample test, what we apply in this one, again you need to check in the data what you want to test. If you want to test mean values, if you want to test the samples through the mean value, then we apply the t-test. If you want to test through the variance, okay, if you want to test through the variance whether the samples belongs to the same population or not, then we go for F test or chi-square test. And next, if you want to test independence of attributes, okay, independence of attributes, that means whether the variables are having a relation or not, you need to check the association between the attributes. What is the meaning of this? Later I'll explain in detail. So in that case, we apply the chi-square test. Okay, again you need to remember, again you need to remember, see, if we are having one sample, we apply t-test for single mean. If we are having two samples, then if it is a two samples are dependent, then we apply the paid t-test. If the two samples are independent, we apply the t-test for two means. Okay, and next one, F test. If we are having two samples, okay, if you are having two samples and you want to test through the variance, then we go for the F test, and that both the samples must be independent. And if there is only one sample, if there is only one sample through the variance you want to test, then we go for chi-square test for single variance or chi-square test for variance. And next, if we are having the attributes, that means if you are having the qualitative variables and you want to test the qualitative variables are having any relation between them or not, then in that case, we go for chi-square test for independence of attributes. Okay, so what it is, first you need to check it, what variables we are having and what through what statistic you want to test. Then based on that, we decide which test can be applied. Okay, so is it clear, ma'am?
Yes,
Is
ma'am.
it clear, ma'am?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah, thank you. And now, so this is a inferential statistic. These all are the tests I'll be explaining through the example and the case study. And one more, you may get a doubt. For the large sample, okay, which test we apply? Large sample, it can be the mean, median, sorry, it can be the mean, variance, or the correlation, or the association, can be anything. We apply normal test only. Okay, so whether it is a single sample or the two samples can be anything. We apply the normal test only. Clear? So if the sample is the last sample, then we apply normal test. Okay, if time permits, that problems also will check. If not, we'll just stick on to the small sample only, because small sample are more important than this last sample test. You may get it out. Why it is more important? Because always population variance, it is unknown. Maximum the population variance will be unknown. So that in that case, we cannot go for, okay, if the population variance is unknown, we cannot go for the last sample test. That's what we go for the small sample test. Okay, yeah. Any doubts in this one, ma'am? Is it clear? Inferential statistics, it is over. Is it clear, ma'am?
Yes, ma'am. Yes, ma'am.
Thank you. So what I have planned in the testing of hypothesis, that is done. And now we are moving to the probability distributions. Okay. Generally, see, always through the sample only we are giving the conclusion. No, it is not always, right? So based on the entire data also, we will be giving the conclusion, right? So based on the entire data, if you are giving the conclusion, not through the sample, then you need to check one thing, whether it is an inductive process or deductive process. So inductive process means what? The inferential statistics. Based on the sample, you are drawing the inference about the population. It is called the inductive process. Okay. And next one, what is a deductive process? Deductive process means you're not considering a sample. Okay. Or if you consider also, no problem. In the data, the particular variable follows some distribution, okay, based on some probability. You will be finding what is the chance of getting some outcome. Then in that case, we go for the deductive process. That means through the probability distribution, you are giving the inference about the population. Okay, so remember, through the sample, if you are giving the conclusion to the population, that is called the inductive process or inferential statistics. Next, deductive process means what? Through the probability law or through the probability distribution, you are giving the conclusion about the characteristics of the population. That is called the deductive process. For example, I wanted to know in tossing of a coin, generally, why I'm giving the simple example means everybody will understand. So, in tossing a coin, what is the probability of getting head? So that is, here I'm concentrating on the probability. So through the probability, you are giving the conclusion. Okay, if I'm telling that 70% chance is there to get a head, then this is called the deductive process. Clear? So through the probability, you are giving the conclusion to the population. Okay, is it clear, everyone? What is the difference between these two?
Yes, ma'am.
Yeah, thank you. And now, see, based on the probability, you are giving the conclusion to the population that you understood. Now, here, what is the probability distribution? Okay, based on what probability distributions, you are giving the conclusion. Okay, so there are some four majorly used probability distributions are binomial distribution, Poisson distribution, exponential distribution, and normal distribution. These are the four distributions which are very important. Okay, now you just see in this one, what is a binomial distribution? When to use binomial distribution? For example, you are conducting an experiment, and in the an experiment consists only the two possible outcomes, and you wanted to calculate probability of a certain number of successes. Okay, then in that case, we go for the binomial distribution. Remember, in an experiment, we are having two possible outcomes only, whether the success or failure. Okay, and or yes or no, true or false, confirmed, not confirmed. Like that, only two possible outcomes are getting. Okay, through the what is that? Through the one particular distribution or through the probability. Okay, then in that one, I wanted to know what is the chance of, or what is the probability of getting a particular number of successes. Okay, getting a particular number of successes. Then we apply binomial distribution. Understood? And next example, here I gave that. For first example, it is a number of side effects from the medications. So number of side effects from the medication means what? Here you just see. Here an example I told you. Suppose it is known that 5% of the adults who takes a certain medications experienced negative side effects. Okay, so through the particular one medicine, 5% of the people experienced negative side effect. Now I wanted to check, see, that means what is that? By using a medicine, how many possible outcomes are there? Whether it can give a side effective or not side effective. Only two possible outcomes by using that medicine. So here we apply the binomial distribution. Now here I wanted to know, out of 100 members who used this medication, what is the chance of getting 10 patients are getting experienced a side effective. Okay, experienced a side effect. So in that case, to calculate that probability, we use the binomial distribution. So I hope, is it clear? Is it
Yeah.
clear?
Yes.
Yeah, thank you. And next one, go for the next one here also. Number of spam emails per day. Is it follows the binomial distribution? How it is, you please let me know, any one of you. Don't read the content what it is. Just check it. Example I gave. Number of spam emails per day. Is it binomial or not? If it is, why? Is it binomial? Is that example follows the binomial distribution? No. Okay. Let me know. Just see. Once the mail you got it. So what is that? The mail, it can be getting into the inbox or into the spam. Right? So once if I'm sending a mail to you, it may go in between these two only, in inbox or in a spam. Right? Only two possible outcomes. So, and here I wanted to find probability of number of spam emails. Okay, probability of one success, sorry, one thing between the two outcomes. Okay, one outcome between the two possible outcomes. So here I can apply the binomial distribution. Clear? And next one, here example I gave. What is that? Suppose there are 20 mails are there. Okay, 20 mails I have received. Then now I want to check what is the probability of among the 20, 3 mails are spam emails. Okay, so here for the calculation of that probability, we apply the binomial distribution. Okay, now go for the Poisson distribution. When to apply the Poisson distribution? Remember, if the sample size is very large and number of successes are very small, then to calculate the probability, we apply the probability distribution. That is a one case. And next one is what? That is, if you wanted to know in a fixed time interval, what is the chance of getting a number of events? Okay, so for example, I gave a 1 hour time for you and I gave 50 questions to you. Now I wanted to know in 1 hour, what is the probability of solving 40 questions? Okay, so in this case, I can apply the Poisson distribution. So in fixed time interval, what is the chance or what is the number of occurrence of number of events? In that case, we go for the Poisson distribution. Example, you just see number of calls per hour. So here it is what? I'm concentrating on a per hour. It is a fixed time. So in that time, I'm focusing on number of calls. Okay. So example, 20 calls in hour. What is the probability of getting 20 calls in hour? So the probability of the 20 calls follows the Poisson distribution. And another one, number of arrivals at a restaurant in a particular day, how many people are arriving? That is number of arrivals. For example, in a day, probability of 130 customers. arriving at a restaurant. In that case, we go for a Poisson distribution. Okay. And next one, it is a clear Poisson distribution is clear, everyone? Can I get a reply?
Yes, ma'am. Yes,
Yeah.
ma'am.
Thank
Yes,
you
ma'am.
so much. Yeah. Next, go for the exponential distribution. It is quietly opposite to the Poisson distribution. What you are doing in the Poisson distribution, you are fixing a time, right? So in that time, what is the probability of occurring of an event? So you are concentrating on an event. Okay, then that in that case we go for the probability distribution. So exponential distribution means what? It is quite opposite to the Poisson. Here what it is, you are not concentrating, you are not fixing a time, you are fixing a number of events. Okay, you are fixing a one event. Example, you are fixing a one event, and how much time you are taking to fix getting that event. Okay, how much time you are taking to getting that event, it is called a, in that case we apply the exponential distribution. Clear? So exponential distribution is what? It is a probability distribution primarily concerned with the calculation of the time when an event may occur. Okay, so example here I gave lifespan of electric gadgets. So here I'm talking about what? Lifespan. That means it is a time. For example, I have gone to a one electronic gadget shop, and I asked him what is the lifetime of that laptop. I wanted to purchase one laptop, and I asked him what is the chance of, that means what is the how many years this laptop will work, right? So what is the shop owner will be telling you, that means he says that, or a salesperson will says that, okay, the life of a laptop is, it is 10 years. How he gave the 10 years, that is based on the exponential distribution. Clear? So what is that? Lifespan of electric gadget. Okay, the laptop works or ends. Okay, that is only the one event. Before that, how many years of time it is taking to work properly? You are focusing on a time. Then in that case, we apply the exponential distribution. Clear? And next go for the purchasing flight tickets. So you just see, when you are booking a ticket to go someplace, so to go to some place, what is that? If you're purchasing 1 month before, the price of a particular item, that particular ticket will be less if you're comparing with the, if you're purchasing a day before, right? So how much amount they are reducing? Okay, how much amount can be fixed, okay, before this much of time? Okay, so that case also we apply the exponential distribution. Clear? And next one, this is also time that an interviewer spends with the candidate. Okay, example, you just see how much time a person, employer is taking a interview for a one person. So here again, I'm concentrating on a time. Okay, so for that case, we apply the exponential distribution. Clear? And next move to the exponential distribution. Is it clear, everyone? Is it clear, exponential?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yeah. So remember, if you're focusing of an event up in a one particular time period, then go for a Poisson distribution. If you're focusing on a time for a one event, then go for a exponential distribution. Remember that. And next one, normal distribution. See, in any analysis, before going for analysis, what we see that whether the data follows the normal distribution or not. How you will decide that? That is, when you are plotting a data, the data should have one peak. That means it should have a uni-model. Uni-model means when you are plotting the values on the graph, you should have only the one peak, and it should be a symmetric. Symmetric means what? From that peak, how much area you are having at the left side, the same area you should have a right side. That means what is the meaning of that? The shape of the curve must be a bell-shaped curve. So example here you just see bell-shaped curve. Yeah. So when you're plotting the values on the graph, you will be getting the shape like this. So what it is, only one peak is here, right? So this is a unimode. We'll call it as a unimode. And it is symmetric. How much area you are having at the left side, the same area you are having at the right side. Okay, this is the second condition. And you should have a bell-shaped curve. Then we say that the data follows a normal distribution. And other than that, without a graph also, you can check if mean is equal to, median is equal to mode. Then we say that the data follows a normal distribution. Clear? So where you get this peak point, that is based on this value, where you have this 3M values. Okay, so that point will give you the maximum peak. Got it? Maximum frequency. Got it? So example here you just see that. Yeah. So here you just see that example. Here you just see I have given you a birth weight of a babies. So birth weight of a baby is what I have taken weights from 6.7 pounds to 8.5 pounds I have taken, and number of babies in that particular weight. So I came to know that here nearly 12 people are having a 6.7 pounds and 35 people are having a 6.8 pounds, and like that 130 members are having a 7.4 pounds. 150, 140 children are birth weight is it is 7.5 pounds. Like that it is there. So I checked and I have drawn a graph on, I have drawn a graph. Then through this graph, I will be checking. So here I'm having only one peak. One peak means only one height. Example here you just see when you are plotting, if you are getting like this, so it is not a normal distribution, because here you are having one peak, here you are having another peak, here it is another peak, here it is another peak. So it is not a normal distribution. Clear? So here what I'm having, only one peak. Clear? So one peak only I'm having, and it is a bell-shaped curve also. How much area I'm having at the left side, the same area I'm having at the right side. Therefore, the data, the birth weight of a newborn babies follows a normal distribution. Similarly, you just go for the height of males, and next shoe sizes. Okay, example, these are the examples of the normal distribution. Is it clear, everyone? These are the probability distributions. Any doubt anywhere? Is it clear, everyone?
Yes, ma'am.
Yes.
Yeah. So this is done. Okay. So what is the basic statistics? What I plan to explain, that is over. Now I'm entering into the one. What is that? Problems. I'm entering into the problems. So let me close this. Yeah. So these are the problems what I have. Now, see example. Now here I'm explaining each concept through different problems. Don't worry, what is the meaning of all this? You'll be understanding how to apply the statistical technique. And in day after tomorrow, I'll take a case study and I'll be explaining how to do the analysis by applying all the statistical techniques we use in one case study analysis. Okay, so for that case, that means we are going like this. Okay, so just see here I'm having this one. What it is, here I have a data. It is a data or in a particular, it is collected from in a particular community. So I have checked that how many children are there in a community, and they are going in which activities. Okay, they are going for which activities in their evening times. Okay, other than studies. Then I came to know that 30 children are going for dance, 40 children are going for music, 25 children are going for art, 20 children are going for cricket, and 53 children are going for football. Right? Now, here I wanted to represent in a particular diagrammatic presentation. Now check it. Before going for the present visualization, check it whether the data is a qualitative data or a quantitative data. Okay, so now here you just see I have a qualitative data activity. The character activities are nothing but what? Dance, music, art, cricket. These all are different activities which cannot be measurable. This is only an activity name, right? So it is activity is a my variable which is a qualitative. And for each activity, if you are having only one frequency, okay, for each activity, if you are having only one frequency, then we go for this simple bar diagram. Remember, so what it is? Number of children, 30 members. That means it is a frequency. 30 children are there in dance, 40 children are there in music. So this is called the frequency. Understood? So whenever you have like this data and somebody asks you represent this data by using simple bar diagram, then what do we need to do? Just I'm copying this data and going to MS Excel and then pasting here. Okay, I have a data with me. Now, how can I represent in a bar diagram? First, copy the values. Copy the values on an Excel sheet. And after that, just select the data, go to the Insert tab. In the Insert tab, just go to the columns. Okay, just go to the columns and in the columns, select the first chart subtype. Okay, once again, I'm telling you, go to the Insert tab and go to the columns. And in that one, select the first chart subtype. Click on it. So you'll be getting it. And then on this graph, after getting this graph, easily anybody will not understand. You need to give the titles of X and Y axis and the main heading, right? So what I'm doing, I'm just going for the, see, click on this graph, then only you will find this chart tools options in the menu bar. Okay, so you just see if I'm clicking, see, I kept my cursor somewhere else. In a toolbar, can you see what is that? That means in a menu bar, can you see chart options? No. So click on a graph. Then you can see the chart tools. Then in that one, go to the layout. In the layout, click on this chart title. Then select above the chart. Clear? So how can we do this? Once again, I'm telling you, just select the graph, go to the chart tools. In that one, go to the layout. And in that layout, click on this chart title and then select any one of these two. It's up to you. I'm selecting above the chart. Then I got it. Here, write that. Just I'm writing bar graph. Okay, sorry, bar diagram. Okay, heading I gave, main title of the graph I got it, that means bar diagram I got it. Again go to the chart layout, in the chart tools go to the layout, go to the axis title and then go to the vertical axis title, horizontal axis title. In this one, click on title below axis. So what is the meaning of this? Here I'm taking on x-axis activity. What is a character? Okay, what is a variable you are using that you need to mention? Okay, and then you just click on the graph, go to the chart tools, layout and axis title, primary vertical axis title. In this one, you can select any one. I'm selecting the rotator title and here I'm writing that number of children. Remember, always the frequency must be on y-axis. Okay, always the frequency must be on y-axis. Is it clear? So this is a bar diagram. And now I wanted to see the numbers also on the bar diagram. Then how can I do that? On any one bar. On any one bar, right click and then add data labels. You'll be getting the values. So what is that? In dance, there are 30 members. In music, you are 40 members. Like that it is. And if you want to go for the comparison, easily you can do it. What it is if I want to say, see, example, I want to make an admission. That means I want to join my daughter in any one activity in that community. Then I want to, where, what I'll do that, I'll be checking what is a high demand. That means which activities is having a high demand. Then I came to know that by seeing this graph, I can easily say that football is having a high demand. So I can join my daughter in football activity. Clear? So like this, you can go for the comparisons also. And next highest is what? Music. And next highest is what? Dance. Like that, you can go for the comparison also. Is it clear, everyone? Bar diagram, simple bar diagram.
Yes, ma'am.
Yes, ma'am.
Yeah. So now just see next question. Next question. See, I have this data. Let me copy this. And here I'm copying this data. And just see here month. Name of the month. April, May, June. It is a qualitative variable only, which cannot be measurable. What do you say? If anybody is asking, what do you say that which month? Immediately you say that it is April, May, or June, August, September, like that. So it is month is a what it is a categorical variable. Okay. And for the categorical variables, if you are having more than one frequency, then we go for either the multiple bar diagram, or we can go for the subdivided bar diagram, or we can go for the percentage bar diagram. Remember, we have one qualitative variable, and for that you are having more than one frequency columns. Then we go for multiple bar diagram. Here, what do we have? April, May, June. That are the 3 months. So here, what is that? Number of adult visitors. It is in April 300, May 500, June 700. And next, what I have taken? Number of child visitors. It is 200, 600, 600. That means I'm having two frequencies: adult visitors frequency, child visitors frequency for one qualitative variable. Then we go for this multiple bar diagram, or subdivided bar diagram, or percentage bar diagram. Got it? So how can we do that? I have selected a data, then go to the insert, and then columns. In that one, select the first chart subtype only. You'll be getting. Now you just see that here, what it is, multiple bar. Why I'm telling multiple bar? In 1 month, we are having more than one bar. Okay. In one characteristic, we are having more than one bar. So we'll call it as a multiple bar diagram. So remember, blue color represents number of adult visitors. Red color represents number of child visitors. And if you want to get the numbers on the this bar, what we can do, on any one red bar, right click. Okay, on any one red bar, right click and mention add data labels. You'll be getting. And next, on red bars only you are getting the numbers. And on any blue bar, right click and mention add data labels. Is it clear, everyone? This is a multiple bar diagram. And how can we give the title? Select the graph, go to the layout and give the chart title. Above the chart, here I'm writing what it is, multiple bar diagram. Okay, so here I got it. And next one, on x-axis, I want to give the name. Go to the axis title, horizontal axis, title below axis. It is the name of the month. Okay, and next, on y-axis, what I'm taking, number of visitors, whether it is a child or an adult. With the colors you can understand. So adult, here I'm taking vertical, and you can take anything. Here I'm writing that number of visitors. Okay, then you'll be getting this. Clear? So this is a multiple bar diagram. Is it clear, everyone?
Yes, ma'am.
Yes, ma'am.
Yeah, thank you. And next one, I'm going for the same data. I'm applying the subdivided bar diagram. How can we do that? Select the data, go to the insert, go to the columns, and select the second chart subtype. Subdivided means what is that? In one bar, you are dividing into the frequency. What is that number of frequencies you have? Okay, click on it. Now you just see what you got it here. Yeah, you just see that in one bar, you are having the two frequencies, right? So this is called the subdivided bar diagram. In the same way, you need to give a, what is that? Data labels. Here also data labels. And then you can give a heading. You just give the heading, what it is. It is a stacked bar diagram. You can say stacked bar or subdivided. Okay, and next one on x-axis, you just give that what it is a month, and then you just go to the axis title, vertical, anything you can give. Here I'm giving that number of visitors. Okay, this is a stacked bar or subdivided bar. Is it clear, everyone? Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Yeah, suppose if you want to give in a very beautiful form, in a beautiful colors, click on it and go to the mm, design. Where it is. Yeah, in design. In design, you can check it. Here you can use the different colors also. Here I can use like this, or I can use like this, or I can use like this. Whatever the colors you want to apply, you can use like that. Okay, so based on your interest, you can decide which design you can apply. For that one, you just go to the chart tool, designs, you will be understanding, you can see so many colors and so many combinations. Whatever you want to use, you can apply for that. Okay, so is it clear? Designing is also clear, everyone. The background, whatever you want to set, you can set it. And even this background, if you're not satisfied, then go to the right click and then format chart area, and here what it is, fill, solid fill, and here you can decide what colors you want, like this. Okay, so like this you can check it what colors you want. Clear? So like the different colors also you can apply. Yeah, any doubt in this? Is it clear, everyone?
No.
Yes, ma'am.
Yes.
Yeah, thank you. And the last one, with this I'll wind up the class. So for the same data, I'm applying the percentage bar diagram. Go to the columns. First one, select the data, go to the insert and go to the columns. Select this one. Percentage means equal length. Okay, now you just give the add data label. Okay. Yeah, you can use the add data label. And here also you can add data label. So it is telling you that 60% are, these are what? Visitors are what? Adult visitors. And 40% are, it is a child visitors in the month of April. In the month of May is what? It is a 45% are adult visitors and remaining 65% are child visitors. Here also same thing in the month of June, and that's only. Yeah. Any doubt anywhere?
No, ma'am.
Yeah. So the remaining problems, I'll share these questions after tomorrow's session. Then it will be easy for you to practice. Okay. So these all the questions I'll be sharing with you. You just go through the video and you please try to solve it. Then in case study analysis, it becomes very easy. Okay. So if you have any doubts, feel free to ask me. Up to now, whatever I have explained. Okay. Is it clear, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yeah. And ma'am, shall I wind up the session?
Ma'am, I have one question.
Yeah, please, ma'am, please.
Ma'am, the moment when we prepare one Google form to get it filled from people. So it
Okay.
has various questions
Yes.
or types of questions. Some
Yes.
may be with respect to gender or income or whatever. So
Yes.
we have to take each question, and then analysis of that one particular question will be separately. Somewhere we'll apply mean, somewhere standard deviation. For every question, we will be classifying, what we say, analyzing separately. Like what you did now is you took first two questions and you made a bar
Yes.
diagram just to understand.
Yes.
So both the
Yes.
questions were different. Something was talking with respect to male and female. I mean, how many people visited,
Hmm.
adults and children, and one was related to something else. So
Yes.
when in a questionnaire, when we have the answers filled by different peer respondents, so each question has to be dealt differently for analysis.
Yes, ma'am. That is yes, because each question will be it can be a categorical or a continuous, can be anything, right? So for different
Right.
different questions, you need to give different different presentations. So it is not necessary that for all the questions you need to go for the presentation. Okay, which are more
Okay.
important, which you are not using in your analysis, but you are feeling that that variable is important to show what you have collected. For that case, you need to go for the presentation. Different, different. It is based on your interest. It is not necessary that always you need to apply the bar diagram. For one chart, you can apply the violin chart. And for one chart, you can apply, for one variable, you can apply the histogram. For one variable, you can apply the bar diagram. So based on your question, based on your interest, you have to present. If you want, see, all the variables are categorical only, and if you want to show all the variables in a bar diagram only, you can go like that also. There is no rule that you need to go for the different different diagrams. Okay, for our interest and for our presentation, we do accordingly. And it is not mandatory in the questionnaire. All the questions must be represented in a visualization. Mostly, we use the demographic factors only. The demographic
Hmm.
factors only we use in the this diagrammatic presentations in the visualization. So demographic questions means what? The gender, income, the social status of a person, and what is the occupation. These all the things will be coming. Okay.
Hmm.
Yeah. Am I clear, ma'am? What you asked is that only?
Yes, ma'am.
Yeah. Thank you.
Thank you.
Ma'am, one query I have.
Yes, ma'am.
Hello.
Yes, ma'am.
Ma'am,
Yes.
if there is a question with multiple answers, then which
Hmm.
diagram will convert it?
That is all I told. No, multiple bar diagram. For one question, if you are having multiple frequencies, then we go for the multiple bar diagram or a subdivided bar diagram.
Okay.
Yeah.
Thank you, ma'am.
Okay, ma'am. Yeah. Any more doubts, ma'am? Okay. Shall I leave?
Thank you,
Yes,
ma'am.
ma'am.
It is
Thank
very
you.
Yeah.
interactive sessions, and you have given lot of information to us.
Thank you, ma'am. Thank you. I'm very
Ma'am.
blessed that is I'm able to share my knowledge with all the people. If this knowledge is sharing, that may be helpful for somebody means it is. I'm very happy for that. Thank you so much.
Yeah,
Thank you, ma'am.
and ma'am, we are excited about upcoming ones where you have said you will be using real life case studies as well, right?
Yes, ma'am. Yes, yes, yes. Definitely. I'll try to cover two case studies, so which may helpful for you. And I'll try to go for the questionnaire data analysis also, if possible. Okay, ma'am. I'll try
Yeah.
to do that also if time permits, because in my college we are busy with this AQAR work. If suppose time permits, I'll collect the data and I'll do the analysis through the questionnaire also. Generally, I use the secondary data and I'm explaining the analysis part. So that means I'm going to explain that. Suppose if time permits, I'll collect the data and I'll try to explain that also. That means based on the concept, what analysis, that means what questions can be asked and how to ask. And that everything I'll check and I'll let you know that also, if time permits. Yeah.
Thank you so much, ma'am,
Thank you,
for
ma'am.
sharing so many things today.
Thank
And
you.
I look forward for all these new insights of yours
Thank you, ma'am.
for
Thank
coming
you.
upcoming sessions as well. Okay, so thank you
Definitely,
so
ma'am.
much, ma'am.
Definitely.
Yeah.
Yeah. Thank you. Thank you all. Have a good
Thank you,
night all.
everyone.
Yeah.
Night, ma'am.
Okay, can we leave everyone? Thank you, everyone.